Welcome to Clearbox AI YouTube channel. My name is Dario Brunelli, and in this video I'm going to introduce you Clearbox Synthetic Kit, our latest library released open source for the generation of synthetic tabular and time series data. I invite you to check out our GitHub page. You can find the link in the description below. Also check out our documentation and the wiki section to further dive into the features and characteristics of the library, because the whole synthetic data generation process is fully customizable. So here you can find out how you can personalize and tweak your synthetic data generation. Now, let's jump to coding. Here below, you can find the link to a Google Colab notebook with which walks you through an example of data generation. I've opened it here. I've removed some parts so that now we can code together and comment while doing it. So let's start with installing the library. Pip install Clearbox Synthetic Kit with dashes. I've already installed the library in this notebook, so my requirements are already satisfied. But when you'll be done, we can move on to importing some our first packages. So from Clearbox Synthetic, that's how we imported the library. We're going to import from the module utils the class dataset, and from Clearbox synthetic dot generation, this time the generation module, we're going to import tabular engine class. Let's run this. So these two classes are the most important, let's say, for the generation. We have the dataset class, which allows us to import a data frame in the context of the synthetic kit. And then the tabular engine, since our example data frame will be of tabular type, is the core module for orchestrating the whole generation, like we'll see in a moment. Now, let's load some data. We define file path here. I copy pasting this path from to this folder in our GitHub repository, where an example data frame is stored. The data frame is named dataset.csv. Okay, now let's upload this data frame within the dataset class. So we are using the from CSV method of the dataset class, which basically loads the data from a CSV file, where we here are specifying the path to the CSV file. It's named file path and the F name. Okay. Now we can also specify a target column, which in our case is named income, and a machine learning task, which in our case is classification. So the data frame we are uploading now is the census dataset. We can take a look at it writing train dataset dot data. Here is where the data frame itself is stored. We can see that it features attributes like age, work class, education, marital status, occupation, relationship, etc. And the target column I specified before is income here. It says whether the individual being part of the data frame is earning more or less than 50K. And this, in fact, is the machine learning task. So the classification task you can run on this data frame is this one. So stating whether the individual is earning more or less than this number. Okay, let's jump to the synthetic data generation part. As I've said before, here we're using our class engine, which we're initializing here, tabular engine. Okay, so we're passing to it the train dataset, and that's it. And we can start the training with the method fit, to which we are passing again the dataset and also the number of epochs, let's say 200 dataset, sorry, and also the learning rate, let's say, yeah, 0.001. Let's start the training. We notice that we immediately get a warning saying that some rare labels have been aggregated into the other category. Now we will further discuss this warning later on, so let's just notice it for the moment. While the training takes place, we can write the following lines, which are the generation part. We are using the generate method this time of the engine class, and we're passing to it train dataset and then n samples, not num. Train dataset and n samples, so the number of samples that we want to generate. Our training is just finished, so let's run this. And our data frame, our synthetic data frame has been generated. So let's take a look at it. So that's what it looks like. But now to further dive into more into details, let's plot the distributions of some features. I've already defined this function here that you can find in the notebook, which is named plot column distributions. It basically takes up to 3 data frame as input and a list of columns and displays the distributions of these columns for the data frame. We are just going to pass to this function the training data set and the synthetic one. So train data set, don't forget to pass the point data, which is the data frame itself. Then we're passing columns, and let's pass synthetic data frame. Okay, let's see what columns we can pass to this function. We can check them out from point data point columns. Here, so they are age, work class. Okay, let's say we want to see how age looks like, and occupation, and then let's say education. Okay. Then we can also specify here in this function the number of bins that we want to use and whether we want to normalize normalization, I believe, yeah, normalization true. We want to normalize because our synthetic data frame has 1000 samples, while our original data frame, the training one, has 30,000 or more, I believe. So we need to normalize the distributions, compare them, and here we have the results. So this is the age distributions plot. We didn't give it a name, so let's give it some more context. So we can specify the F1 like this label. Yes, we call it training, and the F2 label, like we call it synthetic, so that we have more context. Okay, here we're seeing our labels here. So the blue one is the blue distribution is the training set, and the what is it, pink, orange is the synthetic one. We see that the distributions are quite well matched. This is a numerical feature, age, while we have occupation here, which is a categorical feature, and education as well is a categorical feature. Now we can notice that some labels here, like doctorate, 12th, prof school, preschool, 9th, they are not present in the synthetic data set. And that's related to that warning that we were seeing before during the training. This is because these labels are rare labels that appear in a very low number within this feature, the education column. So in this way, they are removed from this. They are not generated in the synthetic dataset, and they are rather aggregated in the other category label that you see here. This is done for privacy reasons. If some individual has some features that are very rare within in the context of a data frame, it can be easily re-identified even from the synthetic data frame, and thus maybe disclosing very private information from this privacy attack. So to avoid this, these very vulnerable records, these very vulnerable individuals that have features that are very rare, are protected by aggregating these rare features within a different label, which is in this case other. So let's go back to that warning that we were seeing before here during the training. It was saying some rare labels have been aggregated into the other category, like I said. And it also says if certain labels were unintentionally discarded, try adjusting the cut labels threshold parameter, keeping in mind that rare labels are at risk of being re-identified in case of privacy attack, as I said. So we have this cut label threshold, which is a threshold, a parameter of the tabular engine class. This threshold, which is defaults to 0.002, no 0.02, I believe, means that labels that appear less than 2% within their column are aggregated into the other category. If we are not concerned about privacy, we can even set it to 0, meaning that no label would be aggregated. And let's try and see the results in this case. We run again our training. We are noticing that we are not getting that warning again because no label was aggregated this time. Let's generate the new synthetic data frame, and let's go down here to check out the results and how it looks like now. No difference in the age distribution, while we can see going to education, then this time doctorate are fifth to sixth grade. They have some, here it's probably very low, but they have some samples with this label, and there is no other, the other label doesn't appear anymore, meaning that these features have been generated. Um, we have, of course, other methods to evaluate the synthetic data generated. We have a whole library dedicated to that, which is named Sure, but that's beyond the scope of this introductory tutorial. So for now, I hope that you found this example useful. So see you in the next video.